Let's see what we were working on here before we change the tapes. We were trying to change the A3, the little guy, the $2,000 every 2 month number, into an annuity. In other words, we asked the bank, hey bank, he says yes, how much would I have to give you each month in order for you to give me $2,000 at the end of 2 months? And we do that by pretending that the A3 is a necessary future value. So this is in effect F times A over F. It says that the $2,000 future value needed, when F over F cancels A, I'm looking for A, use the A over F column, use the 0.5% table, give me 2 payments. And so 2 payments would give you 0.4988 if you look in the tables. It means you have to give me $997.60. You could easily check this. You would add $997.60 times 1, or times, well, you'd have to raise it to the 12th power, wouldn't you? Not real easy. But anyway, you do that and you'll find that you'll have the $2,000 necessary. That means if you invest $997 each month, you'll have $2,000 at the end of the second month period. You can withdraw that $2,000. Of course, the next month you'll be depositing another $997 forever and forever and forever, and therefore you'll always be able to withdraw the $2,000 at the end of every 2 month period. Now then, the 5-year one, that one's going to be a little funny. Let's think about that. It is nothing but a future value that we need. Let's change it into a monthly annuity, a monthly annual amount. That's the bank's compounding period. The value needed is $5 million. We need it every 60 payment periods, every 60 compounding periods, 60 months. Therefore, F3 is $5 million. We get paid 0.5%. The number of payments that will go on before we need the money and extract it is 60 payments. And you look in the table and you find it's 0.0153. And therefore, in order to get $5 million, you got to invest $71,500 every month, forever. At the end of 60 months, you'll be able to take out exactly what's in the bank, $5 million, but your next payment of $71,500 will be a good start on funding the next $5 million, forever and forever and forever. All right. Now then, therefore, what you have to do is you have to give the bank $71,500 each month. Previously, we found you had to give the bank $997 at the end of each month, and you had to give the bank $8,110 at the end of each month. All you got to do is add up all of the things you got to give the bank at the end of each month, and you'll find that you have to scrape up $80,587.60 at the end of each month, forever and ever, to properly fund the light bulbs, the general repairs, and the major overhauls. Now, you say, you know, I don't want to go to the government says I can't go to the taxpayers and just get $80,000 each month from them, because that's not guaranteeing me that they'll always want to fund that building. So you're going to have to go get the money today, very easily. All I got to do is change my monthly annuity into a present value. The monthly annuity is $80,587 a month, divided by the interest rate that the bank's willing to pay, 0.5% a month. That says stick $16 million in the bank, and you will have enough money there to forever and forever draw interest and make the payments necessary. All right, now, bonds. A bond value is the present worth of the payments that the purchaser or the holder of the bond receives during the life of the bond. They're sold for some number of years in which case a seller normally gives you monthly or yearly money. And then at the end of the N years, of course, you get back the original cost of the bond. That's the way they normally work. The bond yield is the computed interest rate of the value of that bond when compared with the bond's cost. Owner of the bonds normally paid back in two ways. First, you get a series of periodic monthly payments or quarterly payments or semi-annual payments or yearly payments, depends on the bond, until it's retired. These payments are usually given by the bond's rate, the nominal interest rate, times the cost of the bond. Usually they say, look, you buy this bond and for $1,000, and I'll give you 6% interest on it. And so each year he would give you 6% of $1,000 until the bond is due to be retired. If you're paid quarterly, then he would divide 6% by 4 and give you $15 each quarter, every quarter, until the bond was due. Then when the bond is retired, he gives you back the money you gave him in the first place. And your gain, of course, is the interest that you earned on it during the life of the bond. Now, the bond's value, at least to you, would be the present value of the monthly or quarterly or yearly annual annuity payments plus the present value of getting your money back in the future, F. Both of these would be based on the rate of interest that you require. For instance, if I can make 20% interest somewhere else, then, and this bond pays 5% interest, then the bond, the value of the bond to me would be less. The value of the bond depends on the rate of interest that I will require before I'll even purchase it. So, if they ask you for a value of a bond, here'd be an example. What is the bond's value to you? What would you be willing to pay for somebody who had a 10-year bond? It sells for $1,000. He's willing to pay you a nominal interest rate of 6%. And he's willing to do that semi-annually, so what he's really paying you is 3% twice a year. And also assume that to you, money's worth 8%. In other words, say, look, I can get 8% over here if I invest in this other thing, and therefore if this bond doesn't pay 8%, then I don't want it. And the guy says, well, okay, what will you pay for it? That's the bond's value, and it takes into account the fact that I want 8% on my money. The bond's periodic payments would be $1,000 times 3%. So he's going to give you $30 every 6 months. And if you're interested in knowing how much that stream of income is to you, here's what being paid $30 every 6 months is worth to you at 8%. The present value of just the interest part is $30 is the annual amount. You use the Peel break column. 4%. I hope I didn't use 4%. Maybe that's just a typo. Say that's 3%. If you don't get 3% out of this number, well then change it for me. 3% per payment period, 20 payments. That'd be 30 times. Hopefully that's the 3% number. I want to shut the tape off just to find that out. You can fix that for me. Is $407. That would be the present value of the $30 every 6 month stream of income. That's part of the bond's value. Now, when the guy gives you back the $1,000, the present value of what you get on your money, since you want 8% money, would be $1,000 times, it says 4% again, that's looking bad, 3% per payment period. Not only that, it'd be looking bad. Ooh. Well, maybe not, because I'm not sure we got a 3% table in the book. Maybe that's why I changed to 4%, and maybe this really should here That's a good chance. 6, 4. See if they got a 3%, if I might have gotten it. Yeah, no, they don't have a 3. Not a chance in the world. Original problem bound to have said, oh, that is 8%, isn't it? Okay, so those numbers are right. Sorry about that. Okay, so I took a break and I went and checked those numbers are right. They are correct for 4% and 4%. I got tangled up with the 6%. The 4%, of course, is you want 8% interest. So half 8% is 4%, which is what it said before I changed it. All right, so the present value of him giving you $1,000 down the road, you know, giving you $1,000 20 years down the road, or 10 years down the road, 20 payments down the road, it doesn't have near as much value to you as having your $1,000 today. So that $1,000 is worth to you $456 when he returns it to you. So, to you, since 8% interest is what you will require before you're even interested in the investment, you would not pay any more than $864.11 for the bond. If he's willing to sell it for that, then you might buy it. It's the value of the bond to you. Now, the seller of the bond might suggest that the face value of his bond should be based on 6% nominal interest rate. In that case, the computations of what he calls the face value would be 3% instead of 4%. But that's because he's willing to take 6%. If you're not, it doesn't have that value to you. All right. Now, the yield of the bond. The yield of the bond is the computed interest rate of the value of the bond when compared with the bond's cost. So, if you did purchase this bond we just talked about for $864, then its yield would be 8% because that's what we agreed that you wanted, so that's its yield. Now then, let's say someone wanted to cash in that bond bad enough and asked you to buy it for $656 cash right now. You'd probably say, well, yeah, I guess I might, probably, possibly. Well, you know you would, because 8% would only give you this much. You'd only pay this much and get 8%, so you're going to get more than 8%. So let's see what the yield really is of this new bond you just cheated out of this poor old lady. The value of the bond returned in 20 periods times P over F, I yield, 20 periods, plus the periodic payments times A let's say periodic payments, let's say that's A, in other words the periodic payments are A, times P over A, I yield 20, where the value of the bond to be returned is $1,000, that's correct, and the periodic payments are $30 each payment period. So in other words, we're setting the parameters. What are you selling me? I'll give you a bond that's worth, I'll give you $1,000 at the end of the bond's life. Okay, what else are you going to give me? Well, I'm going to give you $30 payments each payment period. That'll be each 6 months. So then I slip over to the side and I see, what am I going to get out of this thing? Well, that means that the present value of this bond to me is $1,000 times, that's the future value he'll give me, so this is in effect F, times P over F gives me P, and then here is the annual amount times P over A. Alright? Now, in the real world, you have to do a little bit of trial and error to figure out these yield numbers. However, on the FE exam, that's not going to be so hard because he's going to give you potential answers. So all you got to do is just plug them in and see which one is right. Now, first off, 4% interest isn't right, 6% interest isn't right, 8% interest isn't right. I mean, I already know the answers for 8%, Making less than that isn't an option. I know I don't intend to make less or 4, so I don't have to worry about those. If I'm really desperate and the guy says, okay, hand in your quiz, I'll mark one of these. At least that cuts my guesses down somewhat. But let's see, you really paid the full $864.11, so you would plug that in to using the 12% number. In other words, the question is the present value, the 864 is if you paid 8%. The present value you truly paid, he sold it to you for $656. The question is that equal to $1,000 paid to you in the future and $30 paid to you semi-annually at a 6% rate? A 6% rate. Wait a minute, where's 6%? I thought we were trying 12% here. Ooh, that's right. We are trying 12%. But that's 12% per year, and therefore it's 12% divided by 2, and that's 6% per payment period. So I got to put the per payment period in here, because you'll notice there are 20 payment periods. Alright, so you go look up the P over F column, the 6% table, 20 payments, you get 0.3118. You look over the P over annuity or P over annual column, 6% interest, 20 payments, 11.4699. And lo and behold, you add this times this plus this times this, you get $655. That's it. That's the answer. So D is the answer. You don't have to do trial and error. Don't even want to do trial and error. Don't want to sit there and try and find I that'll do the job. I already know I will do the job. It's either this or this or this or this or this, and it's not that, and it's not that, and it's not that. So a lot of these problems become a lot easier once you know somewhere among those 5 is the right answer. Now let's talk about rates of return. The minimum attractive rate of return is the highest interest rate or the highest rate of return that you could obtain doing something else with your money. And if you could do that with your money, that's obviously the minimum rate that you would accept. So that's called the minimum attractive rate of return, or MARR. The actual rate of return you would then expect to receive on an investment. It may not always work that way, but you always hope it will, and you won't even accept it if you don't think it will. The actual rate of return could be computed by setting the present worth of the benefits equal to the present worth of the cost. I'll show you how in a minute, and seeing what the rate would be under those conditions. You could also set the annual benefits equal to the annual cost, so the future worth of the benefits to the future worth of the costs. Any of these you could do these, but basically you set the benefits equal to the costs, and from that you compute an interest rate which would actually cause your benefits to equal to your costs. And that tells you basically what interest rate or what rate of return you are receiving on the benefits of this investment with respect to its costs. If that number does not exceed your MARR, then you probably won't accept that investment. Now the investment or the rate of return that you calculate from this is called the internal rate of return. So as an example, find the internal rate of return for the following cash flow. Well, at the end of year 1, you disperse $1,000 for your investment. At the end of year 0, the beginning of the investment, at the end of year 1, you take $250 out, or he pays you back $250, and another, and another, and another, and another. The answer is one of these numbers here. So, what I'm doing here is I'm setting the present we're moving these back in time, worth of the benefits equal to the present worth of the costs, because at that rate of return the two would be equal. And that's how you find the internal rate of return. Now, here are your benefits. Your benefits are $250.50 paid annually. So this is a number, and therefore A times P over A would cancel A, leaving me with the present value of this stream of cash flows to me. At some internal rate of return, that's to be calculated for 5 payment periods. The present worth of the cost, well, there's only one cost, and it's all right now, presently, $1,000. So I can solve for P over AIR5. P over AIR5 is equal to 1,000 divided by 250. So in other words, the ratio of the 1,000 to the 250 is 3.992. So if you go look in the P over A column, and look in the 6% table, and look on the 5-year row, do you find 3.992 in the 6% table? No, I don't. It's too big. Try the 8% table. Incidentally, you'll notice the one I started with was the middle one. And the reason I start with the middle one is because at worst it's either the left and the right, so I only have to, at worst, work out 3 numbers. If you start on this end and start working the numbers, you know which one will be the right one. It'll be this one, and you'll be doing 5 of them to get there. So anytime you say, what do you think the answer ought to be, exam? He says, well, I think it ought to be one of these 5. Start in the middle when you're doing these calculations. That'll minimize the potential of going either way. Now for 8%, if you look in the 8% table, yes indeed, that is pretty close to the number that we computed it should be, and so the answer has to be D. Here's another example. Determine the internal rate of return on a new piece of equipment. The piece of equipment costs $25,000. It increases in productivity. It increases my productivity by 50-50 each year for 5 years. And I believe at the end of 5 years, it'll probably be pretty much junk, but I'll be able to sell it for $5,000 at the end of the 5 years. And the answer is either 2, 4, 6, 8, or 10%. Now then, there are 2 terms which have IRR in it, namely the present benefit due to the annual increase in productivity of 50-50 times P over A IRR equal to the present cost, the annual benefit is also because you're going to get some $5,000 back at the end of the payment period. And so there's 2 terms that have IRR, and they come from 2 different columns. And therefore we can't just add them together somehow and find the answer. And so this case, we're going to have to go to the tables immediately. So first, since the investment will give us back 50-50 each year, 5 years, we multiply 50-50 times P over A, that's an annual amount changing into a present amount, plus the $5,000 that we'll get at the end of our 5-year investment, and that is P over F. The future value is 5,000 times P over F. F cancel gives me the present value of the $5,000 return due to salvage sale for 5 years, and set that equal to the $25,000 that it's going to cost me. I'm setting benefits, the string of cash flows plus the salvage value equal to cost. They want $25,000 for the machine. I try 6%. Why do I try 6%? Because it's in the middle. And 50-50 times, using the 6% column, I get 4.2124. This should say plus, here's a mistake, plus 5,000 times 0.7473. That comes out $25,009. Close enough. Answer is C. If it was If these benefits were not big enough to come up to that, I don't know which way I'd go. And you won't remember which way I told you anyway. Probably I'd try the 8%. If I tried the 8% and things got worse, I'd go down the other way. With a little more thought, you can probably figure out which of these really ought to be more likely, which way you ought to go, up or down on the percent. All right, break-even analysis. Break-even points are found by taking a look at an investment and seeing what might change in that investment. For example, you might change the number of computers your company makes. It's going to cost you, say, $40 million to get the buildings and everything built. Each computer you make is probably going to cost you $300. And if you don't make any computers, then I can tell you you're just several $1 million down the drain. You didn't break even. But if you make a whole bunch of computers, then the profit, because you'll sell them for $3,000 a piece, the profit will more than balance out your initial cost and your cost of $300 per computer until you make some profit. Well, I'm looking for the break-even point, the point at which the number of computers made just barely breaks even so that we don't have any loss and we also don't have any profit. The break-even point's found by varying something like how many you're going to make until that change causes two alternative investments to become equal. Here's another thing that's break-even analysis. There's two things you can use this for. Here you might have two pumps available for purchase. They cost different amounts initially and for maintenance. But one is cheaper if it only has to pump a little bit of water. But the other one will be cheaper if you have to pump a whole bunch of water because it's a more efficient pump, although it costs more to begin with. So which of the two pumps would actually be the better pump, and at which point would be the break-even point when you'd know which pump to buy? So here's an example. Assume you need a pump to remove water from excavations. You need these things all the time. In fact, you're getting ready to go buy another one for this next job. Further, assume that pump A costs $1,800. It costs $1.10 per hour to run it and pump water, and it'll cost you $360 a year in maintenance. However, at the end of its 4-year life, it'll have a salvage value of $600. Another option is to buy pump B. It'll cost you $550. Costs $2.35 an hour to operate, but it doesn't require any maintenance. And at the end of its life, it's just dead. It won't have any salvage value. Now then, the money we're paying to the bank and the money that we could make on our investments, our rate of return is 6%. So, you have some fixed costs. Let me show you a picture from the next page just to indicate this. Here's the outcome. Here's the output of the pump. No, this one's going to work better for a plant, so let me not do that one yet. Here is the annual equivalent fixed cost. This is equivalent to the annual costs. Pump A. Well, Pump A costs you $1,800, and that's times A over P at 6% for 4 years. That says the annual equivalent fixed cost, like an annuity, would be $519 a year. In other words, by losing the $1,800 cost of the pump, it would be the same as saying you would invest an annuity of $519 each year. Now, the reason I'm putting this on a yearly basis is because this pump is going to run some number of hours per year, And so I need to spread this money out in the form of an annual amount. Pump B, on the other hand, only costs $550. So in effect, by buying a $550 pump, you're in effect telling me that that pump costs you $158 per year annually. That's the same amount of money here as money here. Now the salvage value would bring in some money. Pump A has an annual value to you of $600 times the over 6% 4 years.